Hello everyone, welcome to today's session. Today we are going to solve the most important and the most expected diagram based question on the topic refraction at plane surfaces. All of you watch the video very carefully, understand the concept, how the ray diagrams are drawn and practice it. These diagrams are very important from board examination point of view. Alright, let us begin. Yes, the first question is, a ray of light strikes the surface of a rectangular glass block such that the angle of incidence is first 0 degree and second is 42 degree. Sketch a diagram to show the approximate path taken by the ray in each case as it passes through the glass block and emerges. So for angle of incidence, we have for first case it is when angle of incidence is equal to 0 degree. So when angle of incidence is 0 degree for normal incidence. So you know, for normal incidence the ray of light passes undeviated. So when I is equal to 0 for normal incidence, a ray of light passes undeviated. Angle I is equal to 0. This is glass. This is a ray of light traveling from rarer medium to denser medium. For normal incidence it passes undeviated. So the first part is over. The second part of the question, when angle of incidence is equal to 42 degree for oblique incidence, let us draw a glass slab with the help of a scale. Draw a glass slab, neat glass slab. A ray of light is striking the glass air intersurface at an angle of incidence 42 degree. You marked it. So you know, when a ray of light traveling from rarer medium to denser medium, it bends towards the normal. Mark the refracted ray. This is the angle of refraction. Again it is striking the surface. Draw a normal to the point of incidence. A ray of light is ready to emerge from denser medium to rarer medium. What happened? It bends away from the normal. So this is the angle of emergence. So in case of refraction at the glass slab, you know, angle of incidence is equal to angle of emergence being 42 degree. You have to clearly mark angle of incidence, angle of emergence is equal to 42 degree because incident ray and the emergent ray are parallel to each other. If there was no glass slab, what would happen? The light ray would have traveled along a straight line path. So dotted line shows the straight line path of the light ray in absence of glass slab. So here angle of incidence is equal to angle of emergence because the incident ray and the emergent ray being parallel to each other. So you can see that the refraction is taking place at a surfaces which are parallel to each other. A, B, C, D. These are the two, CD and AB are the two parallel surfaces of a glass slab. Alright, clear to you? Got it? Good. Moving on to the question number 2. With the help of a well-labeled diagram, show that the apparent depth of an object such as a coin in water is less than its real depth. Second part, how is the refractive index of water related to the real depth and apparent depth of a column of water? So for the first case, you have to, with the help of a label diagram, apparent depth of an object of a coin, you have to show that it is less than the real depth. So we will attempt the first part. So water is contained in a beaker. A coin is placed here, coin A. We will show the water air interface, separation between water. So this is water being denser medium, this is air. So a ray of light traveling normally from A passes undeviated, you know it. Now a ray of light traveling from A obliquely, striking the water air surface, and as you know that it bends away from the normal. So it is bending away from the normal. This is the refracted ray. Okay, AB is the ray which is going normally. AC is the ray which is incidenting obliquely on the water air surface. It is being refracted and it is being refracted along CD. Alright, so it reaches the eyes of an observer So for an observer, he feels that these light rays are appear to be emerging from a point. So in order to find out that, you produce the ray backward, and this is the apparent position of the coin A dash. Okay, this is the apparent position of the coin. The coin appears to be raised, and for an observer looking from here in the rarer medium, he feels that the coin appears to be raised. All right. Okay, so this is the real depth. The real depth, and what is the apparent depth? This is the apparent depth. We can write apparent depth. And what is the real depth? So the real depth is the real depth of the water. Real depth. Real depth. The real depth of the water. And this is the apparent depth of the coin for an observer who is observing from the rarer medium. Okay, so A dash is the apparent image of the coin which appears to be raised. So the ray diagram is complete. Moving on to the second part. What is the second part? How is the refractive index of water related to the real depth and the apparent depth of a column of water? So you know the relation between refractive index, real depth and apparent depth. Just refractive index is equal to, we know, real depth upon apparent depth. Apparent depth. You just write the relation. It carries 1 mark. So here in first part we have showed that the apparent depth is less than that of the real depth. So here the apparent depth, you can see that apparent depth is less than the real depth. All right. Okay. So the real depth is from top to bottom. That is the real depth, and apparent depth where the coin appears to be raised. Clear? Did you understand? Okay, fine. Moving on to question number 3. As you can see, two isosceles right angle glass prisms are placed near each other as shown in the figure. Complete the path of light ray entering the first isosceles right angle triangle prism till it emerges from the second identical prism. So these are the two identical prisms placed as shown in the figure. We have to complete the emerging light ray. Alright. So we must know the principle of total internal reflection taking place here. So let us solve it. So a ray of light striking the surface here at an angle of incidence 45 degree. This is 90 degree. This is 45. 45. Alright, angle of incidence will be 45, which is greater than the critical angle. The ray of light again further turning to an angle 45 degree here, suffering total internal reflection, striking the surface normally. What happened? Passes undeviated, and striking the first surface of the second prism normally, and again it passes undeviated and striking the hypotenuse of this prism at an angle. What is this angle? What is the angle of incidence there? 90. This is 45. This is also 45 degree. So this angle of incidence must be 45 degree. And further, since angle of incidence is greater than the critical angle, further it is getting turned through an angle 45 degree, striking the surface base of the prism normally, passes undeviated. So this is the emergent ray. So the total deviation is 90 plus 90, 180 degree. Alright. So the diagram is complete. First part is over. And second part, name the phenomenon being displayed by the path of the light ray in the diagram. What is the phenomenon is taking place here? The phenomenon of total internal reflection. Total internal reflection is taking place here. Fine. Did you understand? So draw the neat ray diagram, mark, label all the angles carefully, angle of incidence and angle of reflection, and most importantly mark the direction of light ray with the help of an arrow mark. Clear? Okay. Now let's solve question number 4. The diagram below shows a ray of light incident on an equilateral glass prism placed in minimum deviation position. First question, copy the diagram and complete it to show the path of the refracted ray and the emergent ray. You have to show the path of refracted ray and emergent ray, the first part. And the second part, how are angle of incidence and angle of emergence related to each other in this position? So let us solve the first part. We have to complete the refracted ray and the emergent ray. So read the question very thoroughly. the given prism, the equilateral prism or the regular glass prism. So what is equilateral glass prism? Whose angles are 60 degree each. Each three angles are 60 degree each. Such a type of prism we call it as equilateral prism or a regular prism. Alright. So in minimum deviation position, this is the incident ray on the surface AB. First of all, we draw a normal. This is the angle of incidence. Mark the angle of incidence. So in minimum deviation position, as you know, the refracted ray always travels parallel to the base of the prism. It will be always parallel to the base of the prism. We will name the ray PQ incident ray, QR refracted ray. In minimum deviation position, remember that the refracted ray QR is always parallel to the base of the prism BC. Alright? Okay. Now the QR striking the surface AR and draw a normal, and as you know that it is traveling from denser medium to rarer medium, bends away from the normal. So RS is the emergent ray. RS is the emergent ray, and the angle between the normal and the emergent ray we call it as angle of emergence. Okay, so we have completed the incident ray, refracted ray, and the ray diagram is complete. Emergent ray is also marked, angle of emergence is also marked. The first part is over, and the second part, coming to the second part, what is the second part? How are the angle of incidence and angle of emergence related to each other in this position of the prism? So at the particular position of angle of minimum deviation position, as you know that the refracted ray is parallel to the base of the prism, so at minimum deviation position, angle of incidence is equal to angle of emergence. This is a special case only when in case of minimum deviation position, angle of incidence is equal to angle of emergence. At all position of the prism, the refracted ray will be bending towards the base of the prism. Angle of incidence will not be equal to angle of emergence. So this is a special case of the prism called minimum deviation position. All of you must remember this. Clear? Got it? Now let's solve question number 5. Look at the screen. A prism deviates a monochromatic ray of light through an angle delta, where the angle of incidence at the surface of the prism is angle I. Draw a graph showing the variation of delta with I. On your graph, show the angle of minimum deviation. Second part, what is the relation between angle of incidence and the angle of emergence when the ray suffers minimum deviation? So the first part, I delta curve, we have already dealt with I delta curve in the previous videos. So how the I delta curves looks like? So let us draw the first part, the graph between angle of deviation and angle of incidence. Angle of incidence is taken on the x-axis and angle of deviation delta is taken on the y-axis, as you know that. So what is the relation between angle of incidence and angle of deviation? As the angle of incidence increases, what happens? Angle of deviation going on decreasing. So going on decreasing, it reaches a minimum value. Okay, beyond this minimum value of angle of incidence, if you increase the angle of incidence, what happens? Instead of decreasing, the value of angle of deviation increasing. It starts increasing. So you will get a curve like this, and this curve we call it as I delta curve. So as the angle of incidence increases, you can see that angle of deviation goes on decreasing till it reaches a minimum value. So this is the minimum value, okay, on corresponding on x-axis and y-axis, and this value I call it as delta minimum, angle of minimum deviation. So the angle of deviation goes on decreasing till a minimum value called angle of minimum deviation. Further or beyond that, if you increase the angle of incidence value, the angle of deviation again starts increasing. Clear? So this is called I delta curve. Okay, this is the shape of the graph. All of you must practice this, very important. And second part, what is second part? The angle of what is the relation between angle of incidence and angle of emergence when the ray suffers minimum deviation? See, the question is again repeated. The question basically remains same. Nothing will be asked more than or out of this. Provided you practice the things, you will get full marks. Alright, so what is the relation between angle of incidence and angle of emergence in the minimum deviation position? So at the minimum deviation position, angle I will be equal to angle E, angle of emergence. Clear? So the diagram is, graph is completed. This is the value of delta minimum, angle of minimum deviations. At angle of minimum deviation position, angle I is equal to angle E. So two parts we have completed. Clear? You got it? Moving on to the last question, that is question number 6. Jatin puts a pencil into a glass container having water and is surprised to see the pencil in a different state. What change is observed in the appearance of the pencil? Name the phenomenon responsible for the change. Draw a ray diagram showing how the eyes sees the pencil. Very simple. This is the case of refraction. All of you know it. This is the case of bending of the pencil. So what change is observed in the appearance of the pencil? First part, what happened? The pencil will be seen bent. Right? Specifically, the pencil appears to be bent. So what is the second part? Name the phenomenon responsible for the change. Just name the phenomenon. What is that phenomenon? TIR or refraction? It is refraction. It is refraction. Because you know the consequences of refraction in our day-to-day life. Please remember the consequences of refraction in our day-to-day life. And the third part, you have to draw a ray diagram showing how the ray eyes sees the pencil. So for that, we will draw air, water, intersurface. Okay. A pencil is kept obliquely into the tumbler or into the water. So what happens? A ray of light traveling from the tip of the pencil. So let X P be the pencil. Two rays are traveling or emerging from the tip of the pencil like this. One ray traveling along PS. What happens? After refraction, bending away from the normal. Another ray of light again traveling along PS dash, and again it is again getting refracted. Why it is getting refracted and bent away from the normal? Because since it traveling from water to air, denser medium to rarer medium, it reaches to the eyes of an observer. Here observer is looking at the pencil from the rarer medium, and for the observer, how the pencil looks like. Where is the image of the point P? You have to produce the rays backward. Okay, so you produce the rays backward. So it appears to be raised at the point P dash, and the pencil appears to be bent at the point O. Now the virtual image of the pencil is, the real pencil is XOP. The pencil appears to be bent as XOP dash. XOP dash. Clear? So the pencil appears to be bent at the point O. And now the image of the pencil XOP dash will be seen for the observer. Clear? So we have completed the ray diagram. So this ray diagram is very important. So we have discussed almost all the ray diagrams of the topic refraction at plane surfaces. Practice all these ray diagrams again and again, and you can score full marks. At the end of each chapter, practice the important questions, relevant board questions at the end of each chapter, so that you can understand the concept. Once you understand the concepts, you can apply it. Clear? So keep on practicing. You can score full marks in physics. So that's the wrap up for today. Thanks for watching.